We talked about a data warehouse and a data lake as terms being used to describe data stores that are used to handle analytics data. Now, I would like to talk about the methods being used to move data between systems. For example, the task of moving data from an operational database into a data warehouse or a data lake. The two well-known methods are called ETL and ELT. Okay, starting with ETL. ETL stands for extract, transform, and load. It is the procedure or process of extracting data from one system called the data source, transform the data into a new structure, and then load the data into a destination system like a database. It is important to remember that some level of transformation is applied to the data before it is loaded into the target system. For example, an ETL process can establish an FTP connection to a remote data source and copy one or more raw CSV files, over this protocol. So this is the first step, extracting the raw data from the source system. The raw data will be copied to some temporary staging area as part of the overall process. The next step will be to perform some data transformation, like maybe data cleaning, changing the data structure so it will be more optimized to the new use case. For example, here it will be changing the structure from CSV format to JSON format. Finally, the last process will be to load and insert the data into the final target database using the new required structure. A data warehouse is a classic example of using the ETL method. The data sources are a group of transactional systems. Then multiple ETL processes will be used to extract the raw data, those transactions, transform them into the required new database schema, and finally it will be loaded into the data warehouse. The next option is called ELT. ELT stands for extract, load, and transform. It is an alternative for the ETL. We are using the same elements, but in a different order, meaning extract the raw data from the data source and load it into the database without transformation. The data is not transformed on the entry point to the target system. It will be stored in its original raw format. The systems querying the data from the target database will handle the data transformation. Each system may perform a different data transformation while loading the raw information from the database. The classic use case of ELT is when building a data lake. Just extract the raw data from the data sources and load it into the data lake without performing the data transformation. Now, what are the benefits of using ELT instead of ETL? First of all, it is easier to create and implement such ELT process between two systems because we don't care about data transformation. Secondly, by not changing the raw data to a specific new structure that is optimized to existing use cases, we keep the flexibility to handle a future use case that may not be feasible if we change the raw data. Think about an application that requires to identify the list of objects in an image. The raw data is incoming images. As part of the ETL process, we can load the image from the data source, run some process to identify the objects in that image. This is like the transformation phase of our ETL process, and then only store as simple text the list of objects identified in that image. That's it. Meaning we are not storing the raw image files. As you may imagine, it is a very efficient method for reducing the amount of data. We are only storing what is relevant for that use case. However, maybe in the future, a new application will want to identify the list of car vendors in those images. But we are not storing the images. We decided to transform the raw data and store it in a different format. In that case, we can consider using a data lake and then load those raw images using ELT process instead of ETL. It will help us to be flexible in the future. Another benefits of ELT is about a faster processing time, because data transformation is usually a time-consuming processes. The disadvantages when using an ELT method instead of ETL is first of all about storage space. We need more storage space to handle the raw data. Secondly, the data is not organized and optimized for specific use cases. Okay, so it's not 0 or 1. We need to carefully decide which option is more relevant in a specific application.